Okay, we're going to start in a minute or two. The first thing will be to get a Jabber scribe and a note taker. Can we get some volunteers, please? Thank you, Rich. Rich will do Jabber. Looking for a note taker. Thank you. Okay. Are you going to do it in the Etherpad? Or? Okay. So anyone who wants to help, please watch the Etherpad. Okay. The blue sheet's already going around. We just sent one clipboard. Please make sure it sees both sides of the room. Okay. First, as with all IETF gatherings, please note the note well. We just got these volunteers. Thank you. Yes. One of the three suit co-chairs could not be here today. He is available on the Metaco remote participation. This was the agenda we discussed on the mail list. Is there any bashing of this agenda? So since we met last time, we adopted an architecture draft and an information model draft. We received a liaison statement from IETF Study Group 17 regarding secure update of IoT software. We'll talk about that more in a minute. And a hackathon project related to suit went on Saturday and Sunday of this week. At Montreal, we talked about possibly having an interim meeting. The chairs decided not to pursue that interim meeting because internet drafts were not being updated, so it didn't seem that we had enough to talk about. If we want to pick up the pace here, please, authors need to be driving work.
Is the last one? Yeah, there we go. All right, so with one annotation here, other than one annotation, this is the slide that we put up last IETF, right? So all the random stuff is the things that we discussed at IETF 102. And so we had agreement on those, although there was this question. If you look at the charter milestones that are still posted online, they haven't been updated to reflect this yet. So this is actually the most authoritative version is what was on the slide at IETF 102. The annotation is in quotes there in the question line. That's from the minutes of IETF 102, which says, chairs will work with AD to add architectural milestone because when we asked the group didn't have strong opinions on it. And so as chairs, we said, we're going to figure that out after the interim meeting. And as Russ mentioned, we didn't actually have the interim meeting to discuss the documents. And so we still haven't been able to come up with what the right date is for the architecture document. And so they're still on our to-do list. As soon as the architecture document is updated, then we can actually fill that in and work with our AD. Okay. So that's our update. If you see the March 2018 is in red because we haven't adopted any manifest serialization formats as working group items yet, but we have 3 individual submissions. And so that's part of the point of the meeting today, is to focus. So far we've been focusing mostly on architecture and information model. And today our main focus is going to be the manifest serialization formats. And at the end of the agenda, you'll see part of the question is how many manifest formats we will adopt, because our charter allows us to decide whether we ought to adopt one or more than one. We're allowed by charter. Okay, and so we'll have some presentations about that. And then we can try to figure out what the right date to replace the part in red is. Okay. Otherwise, you can see the submit manifest information model as information as July 2018. That one is now a bit overdue, but we think that we are close-ish, but we had a bunch of discussion at IETF 102 that had some changes that haven't been made yet. And so we don't know exactly how close we are, but we think that there's not large open issues. There's just text that needs to be done. Okay. Are there any questions on the milestones? That's just our summary of where we're at. If you have other things that you think we as chairs need to be doing, let us know. But otherwise, that's the update on the milestones, and we will get the posted ones updated to reflect what's on the screen here. Okay, there's no question. I'm going to stand up and do this one. Okay, so I don't remember what the date was, but about 2 months ago, maybe, we had gotten a liaison from ITUT Study Group 17. As you may recall, we got a liaison from them, I don't know, something like 6 months ago, which we presented in a previous IETF meeting. And so this was the slide that we presented then, or I presented then, summarizing what was in the liaison statement then. Okay. Back then, they did not send us the actual document. They sent us a liaison statement that summarized some of the things that were in the document. Okay. And in that liaison statement, it defined 4 terms. The terms, again, this is the slide from the previous IETF where we talked through this. Okay. To set some context. These are the 4 terms, and what we did is in the discussion, which we had first in an interim meeting and at the face-to-face meeting, we said, does it make sense for us to copy these terms and use these same terms in the architecture document so that people familiar with both can actually relate, see how they relate? Okay, and the working group consensus at the time was that yes, that would be a good idea to try to reuse terms where we think it makes sense. And when we talked through it, we said yes, we thought it made sense, and so we put these terms into the architecture document where they appear now. Okay, I put 2 of them in red because in the liaison statement now, okay, I wanted to show the deltas. The part that's in black is basically no change from their document, because this time they sent us the actual document for us to review. Okay, and so that's now posted on the liaison tracker, and so that's the URL if you want to read their full document. It's about, I don't know, 18 pages or something like that. You can find their actual document attached to that liaison there, so anybody in the working group can read it. Okay, which was, okay, sorry, yeah. All right. This is what they've changed. So in the last 6 months, they've had a number of discussions that I'm going to explain based on my reading of that 18 or so page document. Okay, so one of the bullets on the previous, the bullets on the previous slide are the ones that are struck through. So device core is logically renamed to firmware consumer. Okay, as far as I can tell, the meaning is identical. They just changed the name. Okay, the second thing that they did was in the previous slide. If I go back, let's see, go back. Status tracker and communicator in the previous slide. Right, the communicator was something that may or may not be on the device, and it's what keeps track of the status of the device, and it initiates the update. And so we said in a tiny, tiny constrained device, it might not be resident on the actual microcontroller. It might be something that checks the microcontroller and initiates the update, that kind of thing. And the status tracker was something that was not on the device, but tracks the status of the devices under its administration. Okay, so both had similar roles. One was on the device, or typically near the device, and one was somewhere else, potentially in the same location as a firmware server. There's defined as 4 different roles, because they could, in theory, all 4 be on separate physical devices. Okay, go on to the next one. So what they did, and I'll show their diagrams here, as they said, this notion of status tracker and communicator, the functionality that they're doing are so similar that it makes sense to combine them into one term, where that term is more flexible, and we'll show you in the diagram. So what they did is they combined the definitions of status tracker and communicator into one conceptual role that's still called status tracker. Okay. Those 2 were combined, and they had various diagrams. So I'll go on and I'll show you. So the other ones are the same, okay? Because the overall question at the end of this is, should we now map to their updated things? So I'm going to walk you through. See if you can go full screen on this one. Yeah, there we go. Okay, so this So in this working group, we don't do protocol procedure, but in our architecture, we talk about how the manifest format fits into a larger architecture. They also don't do any protocols, but they do try to have an architecture diagram that says how things fit in, and they point to people like us for the actual technical details. So this is their architecture that shows how things happen. Okay? So here's the 4 roles at the top. Now they added an author role, which wasn't on the original list, right? That's whoever generates the firmware. That's another role that we kind of have, but wasn't in the original list, right? So the author puts a firmware image up on a firmware server. Okay? They have a status tracker, which may or may not be on the device, that checks status. The firmware consumer is the actual device, right? The firmware consumer is the thing that's running the stuff that needs to be installed or to be replaced. Okay? So it checks the status, checks the need for an update, initiates the update, goes and grabs the firmware image from the firmware server, and so on. Okay. So here the status tracker is not shown exactly where it is because, again, it could have been on the device or not on the device. Okay. So this is the overall flow that they assume is true in whatever protocol that you're using. And again, they don't define the protocol. This is just the overall flow. Okay. Go on to the next slide. Okay. All right, here we go. So this one illustrates one of the reasons why they've combined. Okay, so here on the left side is showing a IoT device A with a status tracker inside it. Okay. I remember there was 2 types of status trackers in their original terminology, the one that was potentially on the device and the one that was somewhere else, maybe close to the firmware server. Okay. This is showing a case where there's a status tracker that's inside the device. So it's showing that case. Then it's showing another case near the bottom there where there's a status tracker that's near, but outside of devices B and C. Okay. So it may or may not be on the device. Okay. And so this is showing the other roles, the author and the firmware server. Okay. Okay, there's a more complicated one that shows the status tracker here. I didn't include this diagram, but it's there in the document. But the status tracker that's inside in the middle left there, that one, is conceptually sitting over here. And they have more complicated ones where there's change status tracker. There's one status tracker that tracks another one, and so on. So they said there's this general functionality to track the status from something else, which could be the firmware consumer. Or in this case, you can see how the status trackers are chained, right? This status tracker checks the status from this one. These 2 right here were the ones that previously had the different names. Okay, as they've said, the role is the same as checking the status of something, whether that something is a firmware consumer or it's another status tracker. So they just changed these to use the same name because it's notion of tracking the status and initiating update. They said that's similar enough. It doesn't make sense to use 2 different terms for that. Okay, given that this one is already possible to not be on the device. Okay, so this notion of chaining is the discussion they apparently had, and that's what led them to say we don't need 4 terms. Well, 4 if you only need 4 of the original terms. We only need 3 of the original terms. Okay. So that was the main difference in what their liaison statement was doing. Here's some work we've done over the last 6 months, and this was the main change that they did. It was this terminology change and the architecture shown here. Okay. So here we go. It still intentionally does not define any protocols or formats. In fact, they explicitly in their document reference us. Here's the quote from their document. It says, note that the IETF suite working group is currently working on the format of manifest and firmware update procedure using the manifest. Okay. That was their nod to us, saying they're not going to do the work. They're explicitly looking to us to do that work. It also has references to 2 other documents or 2 other activities. It explicitly references the IoT Security Update Workshop, and it explicitly references 1M2M. As just examples of other work in this area that ITUT Study Group 17 is not going to do because these other groups are already actively working on things. Okay. Their document does in fact define requirements for each of those roles, right? The status tracker and firmware concern defines here's the requirements for those. Okay. Now my reading, feel free to read it yourself. My reading is that their requirements are consistent with our requirements that we have in our architecture and information model document. Okay. Unless I miss something, I think that they are consistent, just phrased differently or whatever, but I think that they are indeed already consistent. I couldn't immediately spot something, oh yeah, here's something we need to add to our document. It would be great if we had a volunteer to do another check just to verify that too, maybe ideally one of the authors of the architecture and information model documents. Okay. But that was my personal reading. Yeah, go ahead. Name?
This is Takeshi Takahashi from IETF. Thank you very much for discussing this. I am the person who sent this liaison statement, and I'm attending suit every time. So in the previous discussion, suit people said that you want to keep alignment with the terminology. I listened to that. So from our side, I'm not talking from IETF side, we decided to keep track on suit and try to keep consistency with you. And also, one question actually is, in the previous meeting, you added status structure. Before, I forgot what was the term, but anyway, status structure you added. And maybe it was Hannes who said status structure was not the main component of the architecture draft at that time. So IETF side started to develop more on the status structure. But if status structure is one of the main focus of this working group, I would prefer to discuss here rather than there. So I'm looking forward to the discussion how it goes. Thank you very much.
And by the way, the speaker is the author of the liaison statement. Right.
Yes, and also the draft as well.
Yeah. So if you have technical questions, we ask him. So thank you. Okay. So I guess I should ask, besides the two of us, can I get another volunteer to read the document and look for anything else that we might actually want to change in our document? Since there wasn't anything in the liaison statement that says, here, please change this. Okay, Hannes, thank you. Okay, great. Again, more people confirming that it's already consistent is good. Thank you. All right, so here's our 3 questions. They're similar to the questions that we asked at our interim meeting when we reviewed the first interim statement, first liaison statement. But I'll ask them explicitly. Should we update our architecture document to be consistent with the study group 17 document? Currently, we updated it to match the same language as in the old liaison statement. Should we update it to match the new terminology that they have? And it's the first question. Okay. Let me ask that right now. I see one person who's an editor nodding. Okay. Is there anybody who thinks that we should not update it? Okay. I call that consensus. Because I gave the specific proposal with no objection, so let's go forward with that. Okay. Number 2. Yeah. Yeah, please.
I have to say one thing. The terminology from our side is not perfectly fixed yet. I have seen already some people who are saying some other proposal. So I don't know whether it's a problem for you to change terminology from time to time. But we may have a chance to change it again. Sorry for that.
Yeah, I understand. So if the terminology changes, we'll re-review this. But I think that the discussion that says that the difference between the old 2 terms is minor enough to try to combine those into a role that can be changed and so on, I think is my reading of it was that was a valuable contribution. So speaking as an individual.
So when this is Hannes, when can we expect the final version of the document? Do you know?
Yeah, plan is March, but plan is just a plan. I guess 1 year is needed more. I'm hoping that this work can further first.
Yeah.
Then we want to follow that. That's my idea.
So by the time this goes to RFC, then we can't change it. So you know that, yeah. Okay. Second question. Their document explicitly references us, although it doesn't reference a document, it references the working group because we don't have an RFC or anything yet. But so the question is, should we add an informative reference to the SG17 document to specifically say that they're consistent? In other words, anybody object to that? Because I see nods. Okay, is that fine with everybody? We just added an informative reference that says this terminology and architecture is consistent with the document that was sent. Juan Carlos.
Juan Carlos Enea, CFOXy. I think to say that they are consistent is probably dangerous because of the timelines. Maybe we can say, it's
Okay.
aligned with or something, but
Aligned, yeah. Okay, good point. Okay.
Thank you.
And then the third question is there any reason that we need to respond, given that we have representative here in the room, and the liaison statement did not explicitly ask us a question per se, just, we look forward to working with you and so on, which is great. And so in the previous one, we did not see a need to explicitly respond. It worked, right? And so is there any reason that we need to explicitly respond, or is just the fact that, he's here in the meeting and he can carry back the discussion we have, is that sufficient? I don't see a need to respond. Is there anybody who thinks there's a need to respond? If not, okay, then we're done with this item. Great. Thank you. Okay, so I think next on the agenda was any discussion around, okay, Robin?
Sorry, Dave. Yeah, Robin Wilson, Internet Society, too close to the mic. Something that doesn't necessarily need to be reflected in the document, at least in my view, but something that we should perhaps think about is this idea of chained status trackers. I can see how conceptually a status tracker is a status tracker is a status tracker. But on the other hand, I can also see how the status tracker at the bottom of a chain might be functionally somewhat different from the status tracker somewhere else in the chain. And I wonder if that functional difference might ever be significant enough that it merits a rename, or if conversely, having a configuration where you've got 3 chain status trackers, one in the device, one close to the device, and one remote, is going to introduce real confusion when all 3 of them are referred to as a status tracker.
Thank you, Evan. So shall we go to the hackathon report now? Slides. We have cat open yet. Oops, sorry. The closer to the right.
Yeah, we talked a little bit about the hackathon we did at the last weekend. We actually sort of joined together with the deep group on the hackathon. I'll send you a picture from here. Shows the wiring of the internet. So we had a larger group, and I listed a couple of the names here. It was difficult to take a picture of everyone because people sort of ran in and out somehow. But we also had a few first-timers, and some of them actually didn't stay for the IETF meeting itself. They just stayed for the hackathon. But it was, I encourage everyone to participate at these hackathons because there's a lot of fun. At least on the second day, the first day is always a little painful. What we also had was a lot of hardware to play with. We had this a custom suit board created, which for last time already, which we took with us. And what was new is one group that joined us for the first time in this suit hackathon took a special Renaissance board with them, which used hardware security and required an encrypted firmware image. So that was a subtle variation in what we were doing. So here's what we did at the hackathon. Unsurprisingly, we had a Python tool, and you can actually, at the end of the slide deck, you can see pointers on what we did because we wrote down a few notes, or Hammy did, in sort of like if you want to reproduce some of those steps. Of course, we set up the whole development environment, and many of us did a couple of hackathons already, or work on the stuff on a day-by-day basis. So that wasn't much effort, but Hammy was kind enough to produce a Dockerized development environment. So if you guys want to get some of this working yourself, there's actually now the bar to get started is actually very low. So you kick off a Docker container and then you're good to go. So we did that for EmbeddOS and Riot. And then we used the manifest tool that Brendan has been working on and was extended for this hackathon to generate or to write the manifest in a JSON-based format, because it's obviously nicer, and then use that as an input to produce a manifest in the CBOR COSI-based design. I think there was, Hemi worked also on a CDDL-based version. So we had a couple of different choices on how to create the manifest. And then, of course, we had to then take the manifest and the firmware to the board itself. And unsurprisingly, we had a couple of different options that we used. And from USB to just dumping the stuff in the J-Link to some memory region, or to use co-op and so on. So different ways. And then, yeah, I didn't show that slide at the. So some of those slides were used at the hackathon presentation at the end to inform the participants of what we were actually doing. But I beefed them up a little bit to provide a little bit more context on what we really did. So I hope you appreciate that. One of the things that you obviously have to go through when you work on hardware is you actually need to configure the your system properly. So there are different microcontroller manufacturers. They provide different tools to configure your microcontroller properly. And so in my case, and that's why I took the screenshot from, I used ST Microelectronics for this, for my examples. And so you can, as you can see in the color coding of this microcontroller, you can actually change the whole pin layout. You can enable and disable features of the microcontroller, which is then nice because you exactly enable the features that you want. You reduce the code size, and you can work with, if you, for example, reconfigure or relabel the bin names, you can actually work with symbolic names. You can have a look at this yourself, and there's a utility that you can download. I think it's an insightful exercise if you are like me, like in the past, like to work on overclocking your desktop PC. You will appreciate that functionality. It's basically overclocking on steroids because you can literally change everything in the processor. Quite exciting. And of course, that's the maybe not so fun part, is you have to look at the data sheet to understand like where are things, and I'll show you a screenshot on the next slide. And those data sheets tend to be rather long. So in this case, it was only 1,700 pages long. And one important part is, and that goes a little bit into the architecture document that we still need to update, is to talk a little bit about the bootloader and what the role of the bootloader is and how does it fit into the whole context. In our case, the bootloader was very minimalistic, and we only had one bootloader, so there was no stage 2 bootloader. And that bootloader, or the responsibility of the bootloader is to, it gets executed or started whenever you turn the device on, and then it needs to make a decision about what image to start. So in our case, we also done the security, the suit manifest passing into that bootloader, and also some minimalistic functionality on how to actually access the image. So in case of the USB delivery that I mentioned before, and you obviously need to fetch the firmware from the USB, so you need to have that implementation in there as well. So there are different design choices on how you implement this whole architecture, which obviously has some security implications. And we picked a very sort of basic approach here, which may not be the best one, but I think in discussions in earlier meetings, I think that was type of information and design choices that people wanted to see and also captured in the architecture document. And for that purpose, I talked to one sort of industry expert, Jacob Beningo, 3 weeks ago to help me work on those options, because he obviously has more experience in sort of seeing what the wider industry does in the bootloader business. Okay, so what you see here is that you have flash memory, which is on chip, and there are different sectors. So you typically erase sectors entirely, and it starts in this memory address that you can see up here. And so that's, and I was showing on the next slide, when you reset the processor, it jumps into a specific location, looks up specific addresses. And so when we introduce now the bootloader in this whole process, we essentially have two firmware images. The bootloader is one firmware image, and of course the application firmware, which is nothing else than the real-time operating system plus the application, is actually in another slot, and also it executes the application we really want to execute. And then we use a separate area for the firmware that we want to update. So there's some space that basically is eaten up by having this, or having more than one image. But otherwise, if you mess it up, you essentially break the device. Okay. What you will also find, and I think that's going a little down into some details. And so what you find on these microcontrollers is called a vector table, and you see that this is the vector table. It's just a bunch of addresses. So it starts at this address, and if you look back, so this is essentially address 0, but you have to see it in context of where the code actually starts. So it's this address really. And the first, there's one sort of reserved field, which is the stack pointer. And then the vector table essentially contains just a lot of pointers to functions. And this is the reset handler. It's the first function, and then there are many others. So the processor, if it boots, then it jumps to the reset vector. Of course, if we have two images there, obviously the processor doesn't know where our application image is, so it jumps to the space where the bootloader is. And here, it's a code example on how you actually write the bootloader to make the necessary steps to jump to the actual application firmware. So what it does is, and I'm not going into the details, but it's actually quite simple. You need to configure the stack pointer, which is at the address 0. You need to read the reset handler address, which is 32 bits later, as I showed you just on the last slide. This is your function pointer, and you jump to that function pointer address, and then your application image starts. It's something that we had to go through in our hackathon example when we worked on this, just to give you a flavor of what we were actually doing. We didn't write any assembly code, so it's all on. This is all C. You can all see it's on C. So what did we learn? And like the first day, as I said, is always very difficult because you need to get things working, and there's always something that goes wrong. With all the hackathons I've been to, there's always some problem, and so which required some shop visit. But also, and that was really cool because we had a couple of experts in other domains in the same room, sitting on the next table. So if we ran into some real problem, we could just walk over to them. Which, if you do things at home on your own, that's obviously like easily takes a lot of time to figure out, like then what a small issue is, which the person next to you can just tell you in a few seconds. So that was really beneficial, and I'm actually thinking about like staying a little bit long at the next IETF meeting, sort of an extended hackathon, and try to drag some other people along, because this helped us to make a lot of progress. We also found out as part of this exercise that we had messed up some CDDL and examples in the manifest document, so we need to fix them, or actually Hank has already worked on it, and Carsten did so too, to actually get it corrected. Of course, will ultimately depend on what the group wants during this meeting, but I think we step by step we get there to working CDDL and working examples.
Yeah, Carsten, I have a slight modification with that slide. The CDDL tool is hell.
Okay.
I can sign that, and I'm working on a new version of that.
Okay.
So the next one will be better.
Yeah. Submit a pull request. Just kidding. Yeah, and almost forgot. So already at the last hackathon, sort of the people in the room who worked on the different projects were then at the end asked to sort of give their recommendation for a specific project they liked most, and funny enough, they picked us. So we were quite surprised about this. Thank you, Padu. we're quite happy. Unfortunately, most of our group has already left because nobody expected that we would win. So that's a bad luck. But yes, so that's where we are. There's more information available. So you can look up the details and the write-up. And there are pointers to previous write-ups as well, so you can reproduce it. But don't be hesitant to just approach any one of us, and we're happy to help and give you some of the pointers to the tools that we will be using, and also the or help with the boards and so on. Okay.
Any questions for Hollis? Where are the blue sheets? Could you keep them passing, please?
Who has not seen the blue sheets yet? Which direction do they need to go? Okay. Pass it that way. So next up on the agenda is anything you want to talk about on the architecture and information model. Yeah, you don't have slides.
Yeah. Okay. So short summary on the architecture and information model. That there was this one open issue in the architecture document to talk about bootloader, which is what I just elaborated on. So we still have to work out text. I'm relying on this industry expert to help me do that. Haven't done that yet, so I hope to. We haven't come up with the text yet. I hope to do that. I hope, like from the explanation I provided you just a few minutes ago, I hope that's what you were looking for when you talked about give us more text about the bootloader. That is the type of content I was thinking about: single stage, multiple stage bootloader, what to put in this bootloader, and so on. These type of design considerations. It's nothing really that it has security implications. But it's implementation choice. It's not an interoperability issue, in my opinion. But yeah, there's still some confusion.
Right. It helps to set the context for the architecture and helps people understand the requirements that then appear in the information model. And so I think that the task is to make sure that the discussion is generic enough that it applies to many types of processors. And so there's other people that watched Hannes's presentation about the bootloader stuff and said, oh, well, my bootloader doesn't work that way. Then please comment and help propose text so we can make sure that the text is generic enough, whether we need to cover more than one use case or just have one description that's generic enough to cover all the cases. We'll see. I guess that was part of the point in discussing it now, is to say, this is the style of stuff that Hannes will be putting into the text if this makes sense, but to make sure it's like in the stuff that you walk through, that was the ST Micro example of the bootloader. And if it is different from some other one, then we want to make sure the text is either generic enough, or if there's more than one case, then we cover two cases.
It would actually be the same for all the based microcontrollers. I don't know about others, but conceptually, like the stage 1, stage 2, and what to put in there, I think that's a universal thing. So besides that, I don't think there are open issues with the architecture document. On the information model document, and Dave was kind enough to point me to the meeting minutes from the last IETF meeting to illustrate that we had some open issues there. And the open issues were sort of the alignment with the manifest work. So it turns out that back then we didn't use we used different terms for some of the elements in the manifest compared to the information model. Funny enough, based on the discussion at the last IETF meeting, we changed the names again. So we essentially kept one update. So we now need to figure out, when we talk about the manifest later on, like what the terms finally should be, and we should obviously then get them in sync. I hope that we can settle on the terminology now, on the terms that we use for the different elements in the manifest, so we don't have a disconnect here. But yeah, alignment is a little annoying.
Any other questions or comments that people want to talk about in the architecture or information model documents at this point? Okay, Brendan is coming to the queue. Okay, Brendan, you're up.
So I have a few notes left over from the last time we discussed the information model. What I've got in addition to what Hannes has mentioned is a couple of to-do items, namely the forward references for the threat model so that every element you can walk through either forwards or backwards, either from the problem that it solves to the security requirement that creates to the element in the manifest that solves that, or the reverse, working backwards from each element and seeing why it's there. The second item I've got is that there's an explanation needed that explains that the threat model is incomplete and that there are many elements of a system threat model that aren't actually in there. For example, there are no physical attacks listed in the threat model there. And finally, that needs to be a possibility of countersigning manifests rather than linking them. I think that might have been on the manifest side of things rather than in the information model, but hopefully that's covers the remaining items that would be required to get the information model finished.
Gushavat Grover, Center for Internet and Society. So just wanted to inquire about the resolution of one sort of discussion thread on the mailing list. In my opinion, the manifest and the firmware, in fact, the manifest contains more information than the firmware image. So when we talk about its encryption and security properties of transporting that it should get the same treatment as the firmware image. So just wanted to inquire about where there are.
Hannes, yeah, I remember that discussion. I thought we put some text in there to talk about this, the signing and encryption capabilities of the manifest as well as the firmware, since both obviously contain different information, but both is quite valuable information. And as we've seen also with this hackathon, some of the hardware actually requires you to use encrypted manifest or encrypted firmware images. So I think I'm not saying anything wrong, but we didn't test it at the hackathon. The manifest format can also be encrypted. Yeah, but we should double check. Did you double check on whether we correctly captured that issue in the document? Okay.
Go ahead, Brendan.
I believe that the resolution that was proposed on the mailing list was that this was a good use for transport encryption rather than necessarily at-rest encryption. There are a number of difficulties with going forward with at-rest encryption of the manifest. Not least among them is that this severely limits your ability to use this format in a broadcast environment, since the proposal was that it would be the component which defines how to obtain the key for the at-rest encryption of the firmware. There are a few ways we can work around this, and there are some components that could be encrypted to solve the problem, but it seems to me that there's going to be quite a lot of difficulty in doing at-rest encryption of the manifest itself. I'm not saying we can't do it, and we should probably add some more text to that effect, but I think that it adds a lot of difficulty that's not necessary if transport encryption is adequate.
This is Hannes. So do you care, not you, Brendan, but do you care whether the encryption happens at the transport layer versus at the object layer?
I think the main threat would come from transport, and transport in transit encryption is mostly enough. But I'd be interested in hearing about what you think are the benefits for also doing at-rest, and whether they can also be enumerated in the document if there are multiple options. Sorry, Gushavat Grover, Center for Internet and Society.
Carsten Born, it may actually be useful to have the ability to encrypt the manifest address. And I didn't quite understand the argument that you want to broadcast it, so you use transport encryption. I'm actually not aware that we have solved that problem yet.
Go ahead, Brian.
You're absolutely right, Karsten. That's not a solved problem that I'm aware of. I guess what I meant more was that encrypting the container that tells you how to decrypt itself would be equally problematic.
Karsten, coming back to the mic.
So the right way to do this, of course, is to build an onion. So you have an outer layer that tells you what the security associations are. You need to use the inner layer, which is the one that is actually protected.
Eric, not Mark. So I thought this started with wanting to encrypt the image. Did I miss that? Because right now what people have implemented is the image being embedded in a manifest, which is fine, but we also have the ability to have the image be external, right? And if you care about scale and maybe about this encrypted images, well, just make it be external, and you can get the manifest, but the image and can contain keys, but the image is separate.
This Hannes, yeah, it's correct that we initially started off with encrypting the firmware, which was optionally, so it's not mandatory to encrypt the firmware if you don't want to. And there, which I see as orthogonal, how the image is actually pushed along to the device, whether it's attached to it or whether that's sort of sent separately. But then we went on in the discussion, and that was what the review was about, was should we actually, or how do we protect some of the contents of the manifest itself, because they may be, there may be some privacy related issues there. That's where this discussion on the mailing list came from.
And then if there's nothing else on the architecture information model, we're now going to move into the part of the agenda about actual serialization formats. And so just some background here. As a reminder, our charter allows us, should we choose to do so, to work on more than one serialization format, or it allows us to choose to only pick one. And so right now there are at least 3 individual documents, 2 of which are variations of CBOR and 1 of which is binary. In the past, when we first started the discussion, there was another proposal that was ASN1 based. And so part of this has to do with what's the choice of basic encoding mechanism or encoding mechanisms. And we'll come back to that question after these. And so we'll have people talk about the different individual documents right now and call for whether there's working group interest in adopting this is sort of in scope for this discussion, especially as getting into question number 7, which is really deciding how many do you want to adopt. And so that's where we will actually ask those questions. Okay? And so we have Hank and Brendan and Martin. Brendan and Martin will be doing remote presentations, and Hank is at the mic right now, and so I will let you start us off.
Oh, I can, okay.
No, he's not. There's no slides.
Yeah, I have no slides. This is Hank, not from the floor, but at the mic apparently. So we, the draft name says it all. This is a subset of concise software identifiers. So software identifiers are the ISO standard, and we are remolding that into something more concise and consistent, and that is called concise software identifiers here in the IETF. And there are resource collection in there, and we wanted not only to be able to talk about standard software components, but also about firmware. So why I'm telling you all this? The suite manifest in the last iteration was a set of array elements that were nested, and the concise software identifier is a map structure that's also nested. So by the change of encoding method, with the current manifest from Brandon, it is probably obsolete to continue the specific code version. And my hope is that we can just converge in a way that it's just naturally fitting into each other. So this was basically a proposal, and that's why there are no slides, because it doesn't really make much sense to continue talking about basically the same semantics in different variations. So that's it.
So it's basically folded into Brendan, who is
Yeah.
up next.
Yeah.
And by the way, these are listed in alphabetical order by last name. So Brendan, your presentation is up next. If you want to move into presenter mode. That's Martin's. Brendan, we're waiting for you to present, and if that doesn't work, then go to the queue. We don't have audio.
How about now?
Yes, go for it.
All right, there we go. Okay, so this is a brief summary of what's in the new version of this manifest. If you've had a look at it, it's quite a large document, and most of it wasn't there in the previous version. So there's an enormous amount in there. And with that in mind, I'm going to hit the highlights as much as I can, and hopefully we can have some good discussion more about this on the mailing list. I think there's probably too much to cover in the meeting, so I've done it mostly by example. And with that, I guess, let's get started. Next slide, please. So there are a lot of changes. A lot of it came from the meetings, the mailing list, and a bit of information from the hackathon. I've proposed a COSE digest structure, and I'll need to talk a bit more about that in a minute. And there's a big new feature of severable fields. This is particularly relevant for text components because text, of course, can be very large, and we want these manifests to be very small. So being able to trim some components is important. Next slide, please. Okay, so the COSE digest is a concept I've proposed in the manifest. I've gotten some feedback from Jim Shad, in case he's not in the room, that suggests that perhaps this is too heavyweight for our use, and a simpler solution would be a better choice. So I think that warrants some further discussion. In this case, what I proposed in the document says essentially that we reuse the COSE Mac structure, replace the tag or the Mac with a digest, and use the context of digest instead of Mac 0. Next slide, please. And this is just the CDDL that describes what would be used to accomplish that. Nothing terribly surprising here, I expect. So given that there's already been some commentary from the COSE, or one of the COSE authors, I think that we should probably continue that discussion at a later time, possibly in the mailing list. So let's move on to the manifest itself. These are the identifiers that I was going to suggest for COSE digest algorithm identifiers. I think this is probably still worthwhile that we have specific identifiers defined. It's just a question of whether we should use the structure that I've defined or not. Next slide, please. Okay, so I'm going to go through the manifest, building it up gradually in examples here so that we can have an idea of exactly what's being encoded, how it's encoded, and what the cost is. So if we start with this first example, the idea here is that this is essentially a wrapper for a payload. It's got very little information in it. In fact, we're only encoding 37 bytes worth of actual information that we want. The encoding in CBOR takes us 67 bytes. And the way that's all packed is in the next slide. So first, there's no authentication object. Next, please. And this is how the manifest itself is encoded. We have a version number, a sequence number. The payload defines where it's stored, the size of the payload, and then there is the COSE digest object that I just described. Next slide, please. So a second example, now this one is signed, but beyond that, it's the same as example 1. Next, please. So this is primarily just adding on a COSE sign object. And it is exactly what you'd expect to find in a normal COSE sign object. Next, please. And yeah, good enough. Okay. So now example 3. Here we have the same signature system. A little bit more information to encode. Here we have a payload URI, where to obtain it. We have preconditions, which kind of hardware this would match, and we have a text description. So now we've gone up to 428 bytes of actual information that we're trying to encode, and the encoded size is 605 bytes. This also showcases the point of being able to prune elements. So if the text is trimmed before this is sent to a device, that 428 bytes of information to encode actually drops to only 398 bytes on the wire. And the original size of 605 bytes gets pruned down nicely as well. And likewise, after this payload has been installed and the installation information is no longer needed, that can be pruned to only 319 bytes that are stored on device. Next, please. So here we have roughly the same content in the manifest. We have the COSE digest representing the payload. We also have one that references the installation information and another that references the text. Next, please. The installation information here is shown, shows a matching component ID to the payload that's described in the manifest. It shows a identifier of how to obtain this particular payload, and that's described by an identifier that says what kind of processor is producing this, and a list of inputs, which are a ranked list of URIs, in this case, only one URI. Next, please. And then the text information, which consists of a tag of, or sorry, a key of 1, meaning update description, and 200 bytes worth of text. Next, please. And for the fourth example, it's again the same thing, but in this case, it's using a BSDiff decompression rather than using the, rather than using a raw binary. Next, please. So here, the installation information is the most important part, and it shows a list of 3 separate processors this time around. The first one obtains the remote resource from a URI, as described in the previous example. The second shows where to obtain a local copy to diff against the local resource. And then the third shows using a BSDiff unpacking algorithm and what it should use as its inputs. In this case, using the remote resource as the diff input and the local resource as the local reference. And that's about it. So as a summary of changes, we started with the version 2 of the manifest, and as Hank discussed, tried to converge onto the same format. There was an outer container in the version 2 manifest. It only contained the text format that I've mentioned in here. Now there are some additional elements. There's been a change to using COSE objects in detached payload mode consistently throughout the system, which should hopefully help to make code more compact, since all of the objects are used in the same way. As discussed, the Cose digest structure probably needs to be some additional refinement. To aid with the compatibility with some additional with other IETF standards, primarily COSWID, I've changed most of the structures to CBOR maps. I've defined a manifest lifecycle. Now, this is what leads to the different objects being grouped together and being able to separate some components after they're used. The lifecycle is essentially the process of what components are needed in the manifest throughout its distribution and consumption. So first, text is needed when humans are involved, but once a manifest is dispatched to a device, that can be removed, since devices, if they don't present information, don't need that information. Then the next thing is the set of pre-installation information, which includes preconditions and pre-directives, and those can be pruned when they're no longer needed. And the process continues that way to allow us to remove information when it's no longer needed by the end node. I've added some more preconditions and pre-directives. There are a few left to add. I removed the processing graph that I described in the version 2 draft because it seemed like it was going to require more processing than was necessary on constrained nodes. The tree that I showed in example 4, I hope will be simple enough that it's not complex for a device to process. And the mechanism of placing the resources that a device consumes before anything that uses them in the serialization should also make it easier to consume. I've defined more processors. Some resource information turns out to actually be very similar to processors, so they're combined into a single structure. And after some discussion with other participants at one of the hackathons, I concluded that the storage identifier was actually just the last element in a component identifier list. And that is all.
We saw David Wolfmeyer in the queue. David, are you still there?
Yeah, I'm still here.
No. Dave Wolfmeyer, you're up.
Dave, we're not hearing you.
Dave, we can't hear you. I'm going to push the button again, which may kick you out of the queue, so please get right back in. Okay, yeah, please get back in the queue, Dave. See if it works this side. Okay. Hey, it says you're at the mic, David. Oh, we still can't hear you. Yeah, we have no audio from David.
Okay, well, I can see what his question was. So
Okay, great.
what David asked was, why not reuse the IDs from the named information hash algorithm registry? I don't see a problem with that unless the names are very large, in which case I do see a problem with that. I'll have to take a look at the encoding.
We have two other people coming in the mic. Hank and Kirsten were racing.
Probably the same. Named information is indexed, so you can have an integer there.
Yes, and it's very small from what I see. Yes, yeah. You reusing those is perfectly fine for me.
Yeah, I think also the list you presented, so it's a one-on-one mapping.
Okay, Carson is sitting down, FYI, meaning he was going to say the same thing, I see. Are there other comments or questions on for Brendan? Okay, I see one more person coming to the mic.
Manuel Bocelli, INRIA. Thanks for all the work, and we're looking forward to update our implementation. We had an implementation for 01, and our 03 is a little bit lagging behind. And one thing we'll pay particular attention to is, how complex this is becoming. And we want to play a specific role in this working group, which is make sure that even for single binary, the simplest case of the smallest IoT devices, class 1 bordering class 0, we still can use this stuff. I mean, a manifest format. And yeah, I think the graph is becoming pretty complex, and I'm just wondering how this is going to fit. And I'd like to make sure that in the draft we have the simplest example of how we use that. That's clear, so that people can try it out and see that it fits even on the small stuff. I can already think of maybe some things we might consider simplifying. For example, the severable stuff. Maybe there's a simple way to go about it. For example, right? If we have a way to point to where the firmware is separate from the manifest, we might have a way to point to where the text is separate from the manifest, which might, simplify some stuff, for example. So I'm just, I'm just pre-warning about this. Let's make sure that this stuff is also applicable for small devices, because we want this stuff to be also secure.
Can we go back to example 3, please? Let's see. Yes, Emmanuel, this is the version that should actually meet the requirements that you've brought up. So if we go forward, let's see, 2, 1, yeah, here we are. This is the encoding that we're looking at, and it should cover essentially what you have described. I recognize that the multi-part, the severable fields, may be not ideal for class 1 devices. So the intent there in the draft was that fields could be made severable if necessary, and I specifically call out that it costs encoding size to be able to make fields severable, and so there are many situations where that would not be desirable. The reason I've done what I have in this particular example was I wanted to show the pre-installation information, which is a field that can be made severable, is kept actually in the manifest, so that no additional jumping between elements in the blob is necessary. But at the same time, the installation reference is present, and that means that installation information is external to the smallest part of the manifest. I think that when it comes to targeting class 1 devices, then maybe making fewer fields severable in this way would be at least part of the right answer.
This is Hannes. I think it's also a realization of, like last time and the meetings before, we talked about the different features that people want. But of course, all these features come with a certain price tag. You don't have to use them, but now obviously they are described in a document. And for example, if you use firmware encryption, you obviously have to add extra information. So in this case, it's really minimalistic in a sense of course, there's the signature overhead and so on. But for example, here the firmware is only protected with the hash and the whole manifest is signed. So that keeps it very minimalistic in some sense, but still there's a little bit of CBOR encoding overhead. And I think we'll get to that in an upcoming presentation. But I think it's as Emmanuel said, it's good to keep in mind what we were trying to accomplish in covering a wide range of different devices and keep it as small as possible, so we don't have to mandate the use of all different options for all devices. But currently many of the fields, if not most, are actually optional, so you don't necessarily have to worry about them when you don't want to use them.
Anything else you want to respond, Brendan, before we move on to the next presentation?
No, I think I'm good with that.
Okay, great. And we'll come back when we get to step 7 about how many do we adopt. So Martin, you are up next. You want to move into presenter mode?
All right, can you hear me?
Yes.
Perfect. And you can see me too. Good. I don't have a pretty picture like Brendan had in the background, but thanks for giving me the opportunity to give you an overview of the draft I submitted about a month ago about a binary manifest serialization format. So what I'm going to cover on the next slide is a little bit the thinking behind that, on why we went the way we went, and some implementation on the server side before I jump into the high-level structure of the manifest and a few implementation details, which are a little bit different than others. So let's jump right into the next slide. The key thinking for us was that what Emmanuel just brought up, very, very constrained devices. I want to keep it really simple. And even though if you have a very flexible manifest structure, then it makes it easy to build a very generic update server. For the device, you still have to narrow down. What option the MCU understands and can handle, and an MCU typically only knows about one signature format and one encryption format and so on. So we said I will keep the manifest rather platform specific. So just treat the suite architecture as a general framework, but then some of the fields can be interpreted by the specific MCU in one way or the other. And therefore, you don't need to specify like pre-processing or installation instructions, but you have a type of component you're trying to install. And then usually the installer of that MCU would know where to put that in memory, what type of processing to do on it, how it's encoded, what signature to use, what keys to use, and so on. That way, you can, it becomes much easier to load that manifest straight into memory and execute it right there and then, and maybe even keep it around if you want to do attestation during the boot loading process. You could keep that around and verify the signature during boot as well. All right, on the next slide, so we try to keep it very simple and very small. No need for buffering. Keep the options specific to that platform. I also do not include a URL, but just an identifier, which can then be used to request where to find that particular image, and to request that maybe even one by one in the order the device needs it to install it in pieces. So that way, on the next slide, it provides for a very condensed format, and we think that a simpler format can also be provide less vulnerabilities because it's less code to worry about. But we still wanted to keep it still quite powerful. We can manage multiple images from different authors, which can be signed separately. We can provide dependency graphs for the binary interfaces for the APIs, so that on the next slide, we can provide a single server which can manage the functions of the network operator, the device operator, the OEM operator, and enforce various policies like the rollout speed or rollbacks or targeting by locations and so on. And can also do verification of authorization and dependency checks and so on, all at the server level, because some MCUs might not be able to provide all the checks, different keys and so on the MCU directly. So again, the key is that way the MCU only needs to handle the specifics for its installation, whereas the server has to be a little bit more flexible in handling the differences between the different platforms. It does allow for images in downloads in various ways, through a CDN, or as discussed also as a broadcast. And we favor transport privacy, or another intermediate way would be to use a short-lived URL to make it difficult to intercept those files, such as like an application file which you don't want to put straight on the internet. All right, on the next slide. So let me, so the manifest format itself, I was not planning to go into the details, but it's a nested structure just like the others. You have one big container which then has manifests from different authors. Again, for a very simple MCU, that would be a single manifest. For a little bit more complicated MCU, that might be one manifest for the Wi-Fi component, one for the core OS, another one maybe for the application. Each one of those can have multiple images for multiple components, and each author can provide its own signature so that it can be authenticated coming from the manufacturer, for example, of the application versus the Wi-Fi firmware. And then the update server would sign the whole manifest set with its own signature. All right, on the next slide, a few implementation comments. again, we made sure that the manifest is compliant with the information model. One of the key aspects of this format is that we have an image type, and the image type is defined per MCU platform, so that the MCU installer knows to map that image type to a payload type, to a type of signature. That installer knows how to install it, where to put it, or what type of pre-processing would be necessary. And we use the build date instead of a separate sequence number. And that way we keep the manifest as small as possible, so that we can target even very, very small MCUs. All right, that's kind of the overview, what I wanted to cover. We can jump into any of the details, but I think we don't have the time to do that today.
Hi, this is Hannes. I think your presentation had two components. The first component is the question that also Dave raised at the beginning of the meeting is, should we have, or what format should we have? Like CBOR is a binary format, this is a different binary format. How many formats should we specify? I think that's an important question.
That's the question that will lead after.
Right, but there was also a separate aspect of the presentation, which is we talked about features we wanted as part of the architecture and the information model work. And Martin, in his presentation, argued that he doesn't want to describe some of those fields because for his use case, he doesn't see them necessary. And currently, as you've seen with Brendan's presentation, they are in the document, but you don't have to use them. So for me, a question is, even if we decide to go for different encoding formats, serialization formats, what is the expectation from on what functionality you need to describe in any of those serialization formats from the information model? Is it, do you need to cover everything, or do you need to cover just, for example, the mandatory fields that are necessary? Ideally, I believe there should be, if there are multiple formats in serialization formats, then the semantic shouldn't be different between them, which would otherwise be unfortunate.
Juan Carlos, Brendan, you're after Juan Carlos.
Well, I guess they are going to follow up with Hannes, but my question was different. Juan Carlos Zúñiga, sorry, for Martin, did you check the size of the manifest? Just the total size.
Yeah, let me answer things one by one. Hannes, I think the way I look at it is that those fields are not explicitly listed in the format, because I believe that an MCU can have, for example, a simple lookup table for the various ones. So, for example, the pre-install conditions can be implemented by the installer rather than providing them in the manifest. Or, I mean, again, this is when you look at the implementation, there is additional format for version and so on. You could add fields, yeah.
Yeah, and this is Hannes again. I understand, like in some cases you don't want to use some of the optional features. I think we have no doubt about that. I think my question was more on a different aspect, but maybe I can provide an example on the mailing list on what I meant.
And on the other question from Juan Carlos, no, I don't have the specifics. I can provide an example probably byte-wise, but it depends a little bit on the signature format and so on. Different signatures, of course, have different sizes, and so they end up being different. So, but I can provide on the mailing list, I can provide maybe a typical size or minimum size.
Yeah, maybe try to provide some sizes that would be roughly equivalent to the examples that Brendan walked through. Right? So unsigned, signed, and so on. Some example that is similar to Brendan's. Brendan, you're up next in queue. Go ahead.
Okay, I have two questions. First, when you say loaded directly into memory, can you please elaborate on what you mean by that?
I mean memory mapped straight into memory.
Okay, so what kind of access do you use on that memory? Let's say you're working in C, for example.
I mean, if I can use memory mapped files essentially to load it into the buffer and interpret the buffer directly.
Okay, I understand that. The question I'm trying to drive down to is, are you specifically referring to recasting your buffer as a structure?
Yes.
Okay, that is undefined behavior by the C standard. That may work for one compiler, it may work at one time, but it's not guaranteed to work between versions of the same compiler.
Okay, for a particular platform, a particular set of compilers, that is well defined.
But it's undefined behavior by the C standard. It can change at any time without warning.
Let me jump in here. So, Brendan, if I understand what you're saying, if you're using like a type-def struct in C, that's the case that you're talking about, right?
That's
if
correct,
you're
yes.
using stuff that is a byte buffer and manually casting, the first 4 bytes to a long or something like that, then you can still do it. You're just saying if you're using a type-def struct, then the C99 language has that particular issue. It is possible to work around it. Am I understanding your issue correctly?
Yes, that's correct.
Okay.
The point I'm trying to make,
and Martin is saying that you deal with that in the coder, taking that knowledge into account, such as what I just described.
Yeah, so the point I'm trying to get to here is that you still have a parser. It just looks a little bit different. The second point I'd like to ask is whether you believe that the primary consumer of resources is the parser itself, or if it's the validation of the content.
I don't understand.
Well, I mean, even if you don't have a schema per se, you still have to have a schema. The schema may be simply in code. And I've found so far that in the handling I've done of manifests, the primary consumer of resources is the schema. It's how I validate each part of that manifest, regardless of extracting it from an encoding. What seems to be more significant is the actual handling of the data within it. It all does have to be validated.
Yes, but you are now, what I'm suggesting is essentially to use an array on top of the data structure. And so, yes, you're right that the schema now is in the code, and therefore you're you're working with fixed offsets essentially, whereas in a parser, you have to have a separate buffer which then passes into particular fields.
Okay, thank you.
I saw a comment from Zach on the floor, and so I can either repeat what you said, or you can go to the mic.
So Zach Shelby, so I think this conversation just goes to show that when it comes to the details of processing this kind of stuff in C in bootloaders, you need to do all these things regardless of how this is encoded. So it's kind of a moot point on, oh, you don't need a buffer here, you don't need a buffer there, you don't need to map this. You have to do all those things. I don't really think it makes a big difference either way. Right? So you could maybe drop that. But going to the size issue, so I'm guessing motivation here is because this is slightly smaller than CBOR generic encoding. By what? I mean, Brendan's examples were like 30 bytes larger because of CBOR. Another example was 100 bytes larger. I just wanted to point out that your manifest isn't really your issue here when it comes to constrained networks. You're talking about 100 byte savings versus 100,000 byte firmware. And that's 0.1%. I'm just saying.
Rich Sauls, Akamai. I just want to point out that getting a signature data format right is really hard and really tricky. And so you're just going to use a standard signature anyway. Or you better, otherwise you'll end up on the front page of the Times. And therefore the savings will be even less than you think.
明白semantic So along with the
Drop mic.
hello.
Ming has dropped the. Okay, he's trying to get it working. Is it working now?
Hello.
Yeah.
No, it's working now. Yeah. Sorry. I thought this motivation looks like two sides, right? It's one's the size, right? So size is a good question. What really how significant it is. But the other side you mentioned about the code size. So it's a smaller code to process. You're loading memory directly instead to avoid the parser code and others. But for that one, I still say, what's the popularity that RT devices really cannot handle the CBOR code, CBOR parser. So you have to introduce this because as you introduce a firmware server, the complexity have support two formats. So I don't understand that.
This is Thomas. So this is again a tricky question. You need a parser in any case, regardless of where you store it, because you have to look at the different fields, you craft the fields and interpret the data. One of the arguments that we had initially in the working group when we proposed the ASM1 format was we want to use ASM1 because we had the crypto implementation there for certificates and so on, so we needed that anyway. Then others came along and said, oh, well, but on for CBOR, you're actually going to have that parser there as well because of some of the other work that we are doing in the IETF. So in essence, it turns out that we have that functionality there for other reasons already. So it's kind of, you have to almost look at it from a systems point of view, like what are the other components you have on your systems? Are you adding any extra to it? And that's of course difficult to judge in isolation of not knowing how exactly your system is.
But the assumption would be that you would have, that you use the CBOR parser somewhere else in the system. What if you don't? Yes, you do need some signature format, but that doesn't, if you just use a simple key, you don't need ASN1 or even CBOR is not necessary.
Okay, are there any other questions from Martin? Okay, thank you. So the next thing is the discussion of how many manifest formats we want. Clearly that has already started in the last few comments from the microphone. So one of the differentiators in the presentations we just heard is how much you're going to leverage an identifier and learn implicitly based on that identifier what processing needs to be done for a specific platform. And as opposed to required fields in a structure. So what does the group think needs to be done across all of these platforms? And will one format do it, or do we need specific platform-specific choices? And how do we describe them? Those are the questions I think that are before us, which will ultimately lead to the answer to the question, how many we want to put forward in RFCs. Nobody wants to talk about that in the night? Okay.
Alexander Fellows, Aclio. So the first thing I think is that we need to get at least one right. So that's for starters, and then I would really like, maybe there will be more, but at least one that we get it right, and then to have the same semantics across the different, if there is something else. So let's focus on one, do it right, and then if someone wants to, add like binary stuff or other things, then just add like the corresponding mapping to the baseline format and the baseline semantic that was defined. If I go back to the example, I mean, if we have CDL to define like the CBOR schema, then, if you need to redefine the whole thing for a binary thing, then, you need to do all kind of complex stuff if you try to solve the two problems at the same time. So for me, it seems pretty simple to say, okay, well, use one format, one schema language, and then, just define mappings to binary stuff.
So to comment on your first part, doing zero manifest formats is not an option in our charter, but doing one or more is.
Yeah.
Hank?
This is Hank at the mic. Actually, I was not always in the room. So has Matthias Wellisch commentary on the email list been covered here already? Otherwise, I will bring it up. So he wrote an email to the list with respect to the discussion in the room and said, I didn't get the discussion totally today. Just as a reminder, the Suite Working Group Charter says explicitly this group will focus on defining a firmware update solution taking into account past learning from RFC 4108. Thank you, by the way. And other firmware update solution that will be usable on class 1 constrained devices as defined in RFC 7228. Thank you, Carsten. In essence, devices with approximately 10 kilobytes of RAM and 100 kilobytes of flash. So that is maybe a reason why to have subsets and optional fields in manifests. Maybe we're addressing that, but we should address that explicitly, I guess.
This is Hannes. I was trying to respond to that comment. So I think the goals haven't changed. And as you've seen from Brendan's presentation, there's the options, which you don't need to use. If you have, you don't need a feature, don't use it. As long as you can fit, I think the biggest code size is really with the crypto algorithms, to be honest, and RAM utilization as well. So as long as you can fit the signature algorithm in there, I think you will be fine. The sequence number, the version number, and the value for the hash algorithm probably won't kill you in storing that as well. It's still there. Actually, one other thing. So if you do the processing in the bootloader, the crypto processing, the good thing is there will be no other code running at the same time because there's a minimalistic. So you will have all the RAM at your disposal, which is a good thing.
Dave Taylor. So I came out here to make it clear that I'm talking as a participant and that the rest is acting as chair for my comment here. So I think part of the question that I see people talking about is, and I think Hannes gave a great summary a second ago, harkening us back to the ASN1 discussion and so on. And so I'll just repeat what Hannes said so I can set context for my question or comment. Back, the very first proposal was, here was an ASN1 format, right? And people said, oh, but I may not have ASN1 in my device, but I'm going to have, CBOR in my device. And so let's do it in CBOR, right? Although if you look at, say, industrial IoT, they don't have CBOR in the device either. They have a whole ecosystem of stuff that's not CBOR based, all the way down to microcontrollers and different things. And so part of the question is, especially in microcontrollers, like what's the space overhead? And I think that's the question people are talking about is what's the overhead in the actual manifest and what's the code overhead that I think Ming was talking about, right? And so from a device manufacturer's point of view, right, they would like whichever one has the least overhead so that it gives the most space for them to do stuff that they're actually trying to do, right? Because the whole update process is kind of overhead. You're designed to be, a washer or a motor or a sensor or a thermostat or whatever it is. And so the more that you can devote to that, the better that you can do on a smaller class processor and save costs and so on. And so the question is how much overhead is there for code and how much overhead is there for the actual manifest format itself, right? So the code and the data. And so the original CBOR beats AS1 argument was the extra overhead was small if you already had CBOR, right? Because you already have that parser. The extra code is minimal compared to ASN, where there's a bunch more extra code. And so if you think about a microcontroller that is in an ecosystem that does not have CBOR already in it for the purposes that it's doing in some other ecosystem, then the question becomes how much extra code and how much extra data is there for each of the different manifest formats? And I think that was one of the questions to Martin is do you actually have the numbers and so on, okay? Now, if there's an argument that says, if I already have CBOR parser, then the one that's the CBOR parser is clearly better because the extra overhead is close to zero because I already have that, right? Then there's a reason for the CBOR one. If there are processors that the numbers come out to say there's a significant difference between adding a CBOR version for code and data is much larger than adding the binary one, then there's a reason that they would say, oh, well, the binary one is clearly the one that I want to implement. Okay? I don't know without knowing the numbers, but I'm saying that's what I see as the core question here is, do we want one or do we want multiple? I'm not worried about how many formats the server has to implement. The server is big. If the server has two different formats, the server can implement both of them. That's not a problem. Okay? That's why we have the information model document in the first place. What I am worried about is making sure that whatever we standardize here is applicable to the widest set of IoT devices as possible so that we get the most success of this working group. Okay? And so to me, whether there's one or there's multiple, it really comes down to the numbers. And if the case is there, the case might be there to say we need multiple in order to maximize the reach of our working group. Thank you.
Brendan first, and then the people in my line.
So you asked for numbers, and the number that has been quoted many times is that there's a CBOR parser that fits in 880 bytes. My argument a few minutes ago was that the schema validation is actually the bigger part. And I'll say again that you don't get rid of the schema validation by changing the format. You just have to do it anyway. So what we're talking about is for CBOR on a device that doesn't already have it, 880 bytes versus however much it costs to implement a schema validation for the content that matches the information model.
Okay, the next person from my line.
This is Dave Robin. Two things, maybe conflicting. This is lessons learned from the BACnet committee, which of course was born in the 80s. We love shaving bytes. We hate every byte on the wire. And so we're in this habit of trying to minimize encoding, minimize everything, thinking about using binary headers instead of ASN headers, things like that. And then came along security and signatures, and it just blew all of that away. So, I mean, every byte, if you save 10 bytes here, it pales in comparison to the size of the signature you put to save those. It goes along with that. So that's just one point. So the point of that would be that I would favor flexibility and extensibility in your formatting, not absolute fixed formatting, because you always, it's easy to parse, but you will regret it as soon as you want to add one more information. So a TLV or a tag or some sort of structure that indicates what the fields are so you can sneak another one in is a better approach than an absolutely fixed format. So having said that, that's one point. My other point is we keep talking about, oh, well, the CBOR library is available or the ASN library is available. As much as I love CBOR, it's available in my application using its memory allocations, and all of it, once it is established and running, is not available in the bootloader. So if it is available, it's because I copied and pasted it and adapted it to the bootloader's environment. It's not really available as is. So let's not make assumptions that just because your application is doing something, that your bootloader can also do it. We recently ran into this in the backnet where we were trying to reuse some high-level application read property ASN coded stuff to get our credentials, and we realized that we're trying to do this from the data link layer. The data link layer does not want to call up into the application layer in order to get this service. And so we actually changed it and made it native to the data link, used a different encoding format. So that all that's saying is the bootloader is perhaps a different environment than your application running environment, and let's not forget that.
Rich?
Yeah, hi, this is from David. Is Martin's proposal intended to address the industrial application scenario that Dave is referencing?
Okay, maybe Martin will get in line to answer that.
We'll leave that Martin. I mean,
Yeah, he responded in Jabber, yes.
Okay. Elliot?
Hi, Elliot Lear. To Dave's point, we're seeing this explosion of formats in various different places already. I have a nagging concern about this, even on the server side, which is, and from the IETF perspective in particular, which is I'm a little nervous about the number of code paths being created and security concerns associated with that. If a code path, if we end up creating a code path that is lightly used, I'm concerned that it won't get the exercising needed to make sure that it actually is secure and remains secure. So I think from this group, if it has to go with two formats, I think that's understandable. I think if you end up with more than two formats, that's problematic.
Zach Shelby, I wanted to go back to Alex's earlier comment about encodings, and I really do believe that encodings are something you do on an information model that's shared between the encodings. I mean, at the IETF, we have a long history of doing that, sometimes well, sometimes badly. But I would not want to see two different encodings based on two different information models. That would be a nightmare, right? For us to implement, and that's what's being proposed right now. So that is out. So if we did want to do what Martin's proposing here, it would need to be on exactly the same information, exactly the same structure, and you're just encoding the elements differently.
My understanding is that both of the proposals believe they implement the same information model. Now, as a working group, we need to validate that, but that was the intent of the authors.
So I do believe that you'd have to redo what's done here in a pretty different way in order to actually standardize this in a working group, if you did too. Now, the other thing I wanted to comment on is that we shouldn't consider these microcontrollers as completely proprietary things. It used to be that everyone handcrafted their real-time kernel with their bootloader, and they did some magic stuff on their microcontroller because they're magic guys. Embedded developers believe they're magical. That's going away. We do have platform operating systems. We're really trying to do open source communities. We're sharing bootloader technology across hundreds and hundreds of different microcontroller targets. And we need to be able to reuse this in a standard way. We're sharing the libraries, even though it might not be in the same bootloader. Those libraries are in the same ecosystem of open source components, very well tested, which is a good thing. And we share that same library between the application and the bootloader and many other places. And the more we can do that, the better.
So I just want to point out that things are changing for embedded. This is not the old world of everything's proprietary.
Juan Carlos, then Brendan.
Yep. Juan Carlos Zúñiga, Seaflux. I just want to do a +1 on Dave and Dave's points and trying to answer the question whether we need one or many. I think it's really coming down to requirements. We need efficiency because we need to make sure that we address all these different use cases, and we need flexibility and extensibility to make sure that we are forward-looking. So I think we just wanted to make sure that we keep those in mind when we address the question. And Elliot also brought up a good point. So I think the number 2-ish could make sense. 1 for sure, 2-ish, but not 5, 10.
I just want to ask the question, are we planning to be standardizing a secure boot header format? I thought we were doing update, but I'm hearing a lot of discussion about bootloaders. And so I think we need to answer that question. Is this about doing update, or is this about doing secure boot? Because if we're talking about what goes in the bootloader and what doesn't, then we have strayed into secure boot, and we're not doing firmware update anymore.
Right.
So just add a little bit more on support of some earlier arguments. In my experience, right, most software really have trouble to find crypto libraries. So firmware can be encrypted and it can be signed. So now update, you need decrypt. You have code to decrypt this large code and also verify signature, verify integrity. That code size is much more significant, larger than just parsing some data, right? With the binary, SQL is already concise, well, by word, concise already maybe small enough, right? So I just say the benefit of using multiple formats versus already challenging the crypto library need there. Maybe this different format do not have that compelling benefit overall. But I say if there's a case where you don't need to firmware encryption for those cases where binary format does save some, maybe, but that I'd like to hear. So whether that use case is valid.
Karsten?
Just moment, 2 data points. First of all, the number that was thrown in the air, about 800 something bytes for a CBOR decoder, that's a generic decoder that includes floating point. If you take out floating point, it's 720, and maybe you can shave off a little bit more. So I don't think that that's really something we need to argue. But I think the more interesting question is whose signatures do we actually validate here? So if we convert between formats somewhere, that means that the old signature that was on the old format, yeah, essentially you can only verify that if you actually still have the old format around. Depending on what is actually the authorization structure of that bootloader, it may be no cost at all to have a completely different format because you resign this stuff anyway, and then you can of course do it in a different format. Or it may be very difficult if the bootloader actually tries to be part of an authorization chain that includes the original signature. Then it's hard to use that if you're not using the same format.
So Karsten, before you sit down, I just want to ask a follow-up question on what you said. Are you advocating one architectural view of the bootloader, or are you saying we need to accommodate both of the approaches you talked about?
I just wanted to put in 2 data points here. So generally, I think that it's not hard to do that part of CBOR that you actually need in a bootloader. So I don't buy the argument we have to do something simpler in a bootloader, but I wanted to point out that there are 2 very different situations where one where you resign by a different authority and one where you are trying to use the original authority, and those have different influences on what you actually can do.
Thank you.
Okay, Dave Robin, following up on what Zach said, and Carson, just to clarify what I'm saying, I'm actually, what I've heard in the past is say, well, we already have CBOR, and the reason was that it was a code size in the device. And therefore the libraries lying there, those 800 bytes or whatever are already there, let's use them. That's not actually my point. I think if you wanted, I don't think that's a valid argument, is what I'm saying. But there is a strong valid argument to be made, sorry, this is a very loud mic, to reuse things that we know and code that is debugged. And so when I said cut and paste CBOR into your bootloader and adapt it to its memory structure, I meant it literally, that's great. That's not a bad, I'm not saying that's a bad thing. You've got this library that works, you might need to use it in another environment. So my point was, don't make the argument that it's lying in memory and I can reuse it exactly where it is. But the technique and the encoding and the code that's debugged, I think might be a good thing. And now, so the second point about clarifying how did we start talking about bootloaders all of a sudden? Because we're getting my patch across my application, across the wire. That's not the bootloader doing that. But eventually you've got to hand it to somebody to apply the patch. And that, to me, that's where my system reboots. That's not really the bootloader, but we call it boot, is the thing that applies the patch, checks the signatures, and then restarts the application. So it's not the application that's patching the application, was my only point.
Brendan, go ahead.
Yeah, the point I was making when I said that was perhaps I was a bit obtuse. What I'm trying to get to is that there are lots of existing formats for bootloaders to verify the integrity of the firmware they're booting. And I'm not so naive as to think that absolutely everyone is going to jump on this format as the mechanism that they use to verify an image before it's booted. In fact, I wouldn't be surprised if a very common use case would be to deliver a component that contains a bootloader signature header already in it, and that the update mechanism is completely separated from the boot validation mechanism. In fact, I would argue that when it comes to separation of authority, it would be highly probable that the authority for delivering an update is not the same as the authority for signing a firmware, and we shouldn't conflate the two. That's not to say that you can't use the header that we're describing as a boot time header, just that I think it might ignore some other system constraints.
I would point out that 4108 does separate those as well.
Dave Robin say, thank you, that's correct. I don't disagree with any of that.
Manuel Bocelli, INRIA. I think back to the question of how many formats we should move forward, I think we all know the answer to that. It's the minimum number. So we already know that minimum is greater than 1. And I think the question is should we go up to 2? Is the decisive factor is applicability to class 1 devices or borderline class 0. Like, if we need 2 formats, so that at least one of them is going to be widely used on class 1 devices, then, well, let's go with 2. If we can do with 1, let's do with 1.
So I guess I'd like to find out what the sense of the room is. Do a hum. So I'd like to ask the question or explain the question I'm thinking of asking and get comment on that. That is, do one and only one manifest format? Yes or no?
Emmanuel Michel, again, are we even ready to hum? That's another question.
I'm trying to get a sense of the
Yeah,
room.
okay. Because I mean, people are still arguing about like sizes, and like we don't even have the sizes of stuff, and like and there's a valid question about like, are we even ready to do that? I mean, I'm just wondering. Yeah, okay.
I think I heard 2 potential questions hidden in there, Russ. This is Elliot. One, I think, goes to what Zach said, which was, will we have a single information model?
We already have a single.
Okay, if that's the case, then I would draw it. Then
the charter says we have one and only one information
okay.
model.
Good.
So yeah, I think I'm Juan Carlos Zúñiga, backing up Emmanuel's point. I don't feel that I'm ready to answer the question. So I don't know if the question is, do we want to answer the question now, or what is exactly what you're trying to get to with the hum list?
Right. Okay. Fair enough. So yes, no, or don't have enough information yet.
Okay, thanks.
I mean, we could have a hum, but like, do we wish to have one? and that, well, whether this wish will be granted, you know, like that's a second question.
Okay. So let me subtly change that. You think this working group should work on only one? Yes, no, don't have enough information yet. Okay, let's do the hum now. Do you think this working group should work on one and only one manifest format? Hum now for yes. Hum now for no. Hum now for need more information. So there was a bit more, for at least from this corner of the room, for one and only one, and there was about half of that for need more information.
It was correlated with location in the room. The people in the front half tend to hum for stronger for the first one, and the people in the back half tend to hum longer for the second one. So it's correlated with those who sit up close.
So we need to mix up where you sit next time.
Yeah.
Okay. I think we need to take that to the list as the next step, but it helped me at least to understand where the people in the room are thinking. Okay, so we're down to the next steps part. Dave?
No. I think you just summarized where our next steps are. I don't have anything else to add. I think the next steps that we know of, just as a reminder, the authors have things Brendan and Hannes talked about. They need to update the information model and architecture documents. And once we see those, then we can decide whether we have consensus on those or what our next step is there, but we need to see the text first. I think Martin has an action item to post numbers that are similar to the sort of numbers that Brendan did. And I don't know, those are the main action items that I can think of. And the chairs have an action item to update the milestones. Thank you. Okay. That's my summary. Thank you for coming, and we'll call it here.
Can we bring the blue sheets up, please?
Actually, we already got them. Yeah. Who's got the blue sheets? Blue sheets? Anyone? Next to Zach.